In North America, February 2nd is typically referred to as Groundhog Day. It is celebrated in Canada and in the United States and has its roots from the German-speaking Pennsylvania Dutch, who based it on the Christian religious ceremony Candlemas and what was also called Badger Day. Candlemas also corresponds to the midpoint between the winter solstice and the spring equinox that was marked in parts of the UK and Europe and heralded the end of winter. The rule, if you will, of Groundhog Day is that if a groundhog exits its burrow on February 2nd, sees its shadow, and retreats, we'll have 6 more weeks of winter. Otherwise, it's an early spring. Hooray! The reality is that North Americans' groundhogs are more often wrong than right, correctly predicting the spring weather a little more than 30% of the time. Sorry, Willie. Another interesting fact about February 2nd is that it's the birthday of the famous Irish author and poet, James Joyce. It turns out that Joyce was a big fan of math and incorporated a lot of it into his writing. One of his more famous examples is a chapter in his novel Ulysses, entitled Ithaca. In this chapter, he uses a series of questions and answers, many of them with a mathematical basis, to move his dialogue along. One such mathematical concept has actually been given a special place in mathematics. It's called a Joyce sequence, named after the author himself. And here's how it works. The sequence is made up of the number of digits in the answer to the exponent n to the power of n to the power of n. For example, 1 to the power of 1 to the power of 1 equals 1. 1 digit. So its Joyce sequence number is 1. Or 2 to the power of 2 to the power of 2 equals 16, which has 2 digits for a Joyce sequence number of 2. Or 3 to the power of 3 to the power of 3 equals 7,625,597,484,987, a 13-digit number. Here are the first 10 values of the Joyce sequence. And we've highlighted 9 to the 9 to the 9, which we'll talk about in just a moment. First, though, a very, very important point. To solve these exponents properly and get the right Joyce sequence values, it's vital to know what order to do the exponents in. For example, if we did 3 to the power of 3 to the power of 3, like this, we get 27 to the power of 3, or 19,683, a 5-digit number, which is very different from the 13-digit number we got by doing it this way. This is where brackets in mathematics can help us greatly, and why order of operations are so very important. The OEIS uses this definition to create the Joyce sequence, which is based off of the section in Ulysses where Joyce writes, he had learned of the existence of a number computed to a relative degree of accuracy to be of such magnitude and of so many places, e.g. the 9th power of the 9th power of 9, that the result having been obtained, 33 closely printed volumes of 1,000 pages each of innumerable quires and reams of India paper would have to be requisitioned in order to contain the complete tale of its printed integers of units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, millions, tens of millions, hundreds of millions, billions, the nucleus of the nebula of every digit of every series, containing succinctly the potentiality of being raised to the utmost kinetic elaboration of any power of any of its powers. Phew! What Joyce is saying, in a very roundabout way, is that to write out the digits of 9 to the power of 9 to the power of 9, it would take 33 books of 1,000 pages each. And it turns out that's pretty accurate. 9 to the power of 9 is equal to 387,420,489. And 9 to the power of this gives us a number with about 370 million digits. If we write 100 digits per line and 100 lines per page and 1,000 pages per volume, this would require 37 volumes to write out the answer. So Joyce's 33 volumes wasn't too far off. Pretty impressive for 20th century math knowledge and no calculators. Ulysses also contains many other mathematical and scientific references, like measuring weight and the effects of gravity, traveling in parallel lines, interesting sequences of numbers, and more. However, it's important to note that there are many mathematical errors as well. Some are purposeful, but it has been hypothesized that some might be potentially due to Joyce's lack of mathematical knowledge. Okay, so what does this have to do with February 2nd, besides it being Joyce's birthday? Well, the first edition of Ulysses, a very limited run, was published on February 2nd, 1922, or 2/2/22, on Joyce's 40th birthday. An interesting fact, 2,222 is a number where all of the factors are palindromes, numbers that are the same forwards and backwards. It's important to note that Ulysses does not take place on February 2nd. Instead, it takes place over one day, June 16th, 1904. In fact, June 16th is now celebrated as Bloomsday, in honor of Joyce's main character in the book, Leopold Bloom. And it's a celebration of the author and the book. One more interesting fact, June 16th, or 1606, is 1,606. It's the sum of 6 positive integers to the power of 5. Specifically, these 6 integers. Yet another fun exponential fact. And so today, on Groundhog Day, Joyce's birthday, and the first publishing date of Ulysses, we celebrate the mathematical musings of James Joyce and hope for a quick end to winter, whether the groundhogs get it right or, more than likely, not.